My name is Robert Mtare and I'll be your tutor. If you haven't subscribed, please do so. If you haven't liked, please do so. If you haven't comment, you already know the word. Please do so. And I hope you enjoy this lesson.
Question 3 has 8 marks, and I'm going to teach you the easiest way to get all 8 marks. Part A reads, define the term interference as associated with sound waves. So interference is the superposition of waves from two coherent sources, resulting in regions of loud and soft sound. Coherent just means both sources have the same frequency, and when those waves meet and combine, that is exactly why you get loud spots in some places and quiet spots in others. Superposition, coherent, loud, and soft. Those are the exact words the examiner wants. Miss them and you missed the mark. Part B Part 1 reads, calculate the path difference L2A minus L1A. Now L1 is directly across from A, so L1A is simply 1.2 meters. But L2 sits 0.5 meters below L1, which means the sound from L2 has to travel diagonally to reach A. That gives us a right-angled triangle, so we use Pythagoras. Square root of 1.2 superscript 2 plus 0.5 superscript 2 equals square root of 1.69 equals 1.3 meters. So path difference equals 1.3 minus 1.2, which gives us 0.1 meters. The speakers are at different heights, that is the hidden triangle. Spot it and the calculation becomes straightforward. Part B Part 2 reads, calculate the wavelength if velocity of sound is 340 meters per second. We use wavelength equals velocity divided by frequency, so 340 divided by 3400 gives us 0.1 meters. Now notice something interesting, the path difference from Part 1 is also 0.1 meters. That is not a coincidence at all, and Part 3 is about to show you exactly why that matters. Same number, two different calculations, keep that connection in your head going into Part 3. Part B Part 3 reads, would you hear loud or soft sound at A? Explain your answer. So we divide the path difference by the wavelength. 0.1 divided by 0.1 equals 1. That is a whole number, which tells us the waves arrive at a perfectly in phase. And when waves are in phase they add up, that is constructive interference, which is exactly why you hear a loud sound. Put it down like this. Loud sound because the path difference equals one whole wavelength, so the waves arrive in phase and constructive interference occurs. Whole number equals loud. Not a whole number equals soft. That one rule covers every interference question you will ever see. Part C reads, state one difference between a light wave and a sound wave other than speed. So light is a transverse wave while sound is a longitudinal wave. Light vibrates at right angles to its direction of travel, whereas sound vibrates back and forth in the same direction it moves. That right there is the fundamental difference between the two. Easiest mark on the question. Never leave it blank.